All right, here we go. The last video of Unit 5, Lesson 4. And we are on to problem 4.3. And here we have Andre, and he says, we know that if a rectangle is scaled by a factor of k, then the area is scaled by a factor of k squared. And that is exactly what we discovered in the last couple videos. Does this apply to other shapes? And Jada says, well, here's a shape that's not a rectangle. Say its area is a square units. Let's draw some rectangles on it that get smaller and smaller to fit the remaining empty space. With enough rectangles, we can come close to covering the whole blob. Andre says, these rectangles start to make a nice approximation of the blob. If we wanted to get closer, we could add even more rectangles. The sum of the areas of the rectangles would add up to the area of the blob. I think we're almost there. Perfect. So let's take a look at what Andre says. And Andre says that the sum of the areas of the rectangles would add up to the area of the blob. So let's name our rectangles. Rectangle 1, rectangle 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so here we have 9 rectangles. Now, I would think that if we want the total area that these rectangles cover, if we just find the area of each individual rectangle and add those areas, that would be the area covered by all of these rectangles. Okay, so the total area of the rectangles would be equal to the area of rectangle 1 plus the area of rectangle 2 plus the area of rectangle 3 plus 4 all the way up to the area of rectangle 9. So if we add all 9 of these, that will be our total area. And that totally makes sense, what Andre is saying. Okay, so let's go here to the next page. And we want to know, suppose the blob is dilated by a factor of k. In doing this, the rectangles covering the blob also get dilated by a factor of k. How does the area of each dilated rectangle compare to the area of each original rectangle? So what we have here is we have our original rectangles. When we have our dilated rectangle, okay, now my total area, I recognize that I'm going to take k squared multiplied by area 1. I'm going to take k squared, multiply it by area 2. I'm going to take k squared, multiply it by area 3, and I'm going to continue to do that all the way up to k squared multiplied by area 9. Okay, so how does the area of each dilated rectangle compare to the area of each original rectangle? Well, the dilated rectangles, or the dilated areas, are the original areas multiplied by k squared. So number 2 now says, what does that tell you about the area of the dilated image? The area of the dilated image. So if I look up here at the top, this will be the area of my dilated image. And what I want to do is I want to focus on the right-hand side here. If I focus on this right-hand side, notice that there's a k squared that is in every single one of these terms. So I'm going to use my algebra, and I'm going to factor that k squared out. Let's make that a little nicer. So I'm going to put the k squared out in front. And what's going to be left when I take k squared away from this first term is I'm going to be left with just that first area. Plus, when I take the k squared away from this second term, I am left with just that second area. Plus, when I take the k squared away from this third term, notice I'm left with just that third area. Plus, and that is going to continue all the way up to taking k squared away from this last area, area 9. Okay, so this is my total area now. I've just rewritten it by factoring out the common factor of the k squareds. Now what I want to do is I want you to focus on this part written in red. Notice how this part written in red is just my original area. So that means my area, my total area of the dilated image is just k squared times the original area of the original total area of the rectangles. So what does that tell you about the area of the dilated image? Well, the area of the dilated image will be k squared times bigger or smaller if k is less than 1. K times bigger or smaller than the original. Perfect. Going on to number 3. Suppose we have a circle that has an area 20 square inches and it's dilated using a scale factor of 6. What is the area of the image? So if I have a circle, the area of this circle is 20 square inches. I know it's going to be dilated using a scale factor of 6. So that means that my new area is going to be the scale factor of 6 squared times the original area of 20. 6 squared is 36, and 36 times 20 is 720 square inches. Okay, so the area of the new image is going to be 720 square inches because it is 6 squared times larger than the original. Okay, so that'll do it for Unit 5, Lesson 4. Reminder, these notes at the bottom here, this Lesson 4 summary is a good generalization of everything that we've talked about. So if you ever want to take some short notes on anything, this is where you should look at that summary. And that's it for Unit 5, Lesson 4.